Ciao friends and welcome to a new video from SQL BI. In this video I want to elaborate on solving the open orders pattern with visual calculation. I was delivering a training in the last few days and one student, by the way, thank you Justin for the question, a student asked me whether it was possible to solve the open order patterns, that is a very heavy pattern, by using visual calculation in order to optimize its execution. So we wrote a first version of the solution, but then, coming home, I decided to work a bit more. So I'm going to first introduce the open order pattern. That is a very common pattern. You receive orders, you deliver orders, and at the end of any given period, there is a given number of orders that you still need to deliver. That is the number of open orders. And we want to compute the number of open orders at the end of every month since the beginning of time in order to evaluate the performance of our delivery department. It's a very heavy calculation written in DAX. And we do have a pattern in daxpattern.com, so if you are interested in the topic, just go there, download and read the code, because you will find very nicely optimized versions of the pattern. However, for this video, I'm going to use a suboptimal pattern that is easier to understand. Then, once we understand that it is slow, because it requires to perform very heavy calculations, we will use visual calculation in order to improve performance. And we will actually succeed, meaning that by using visual calculations, we will be able to highly reduce the time and the memory requirements of our query. However, before the end of the video, using the idea that came out with visual calculation, we will also write a version of the same pattern by using regular DAX code, and it is still better. However, the good advantage of visual calculation is that they are easy to understand, so any user, even with a limited knowledge of DAX, can solve the open order patterns with visual calculation and very good performance. Then, if you are really keen to write the perfect DAX code, regular DAX in this scenario is still a bit better. However, with no further ado, let's look at the demo. I'm going to use our usual model, but this time I'm only interested in a couple of tables that are sales and data. And I'm going to focus on the fact that sales and date, they share two relationships. One is with the order date and the other one is with the delivery date. So sales is related to date through two different columns. The default relationship is the one with order date, and the inactive relationship, this one that is dotted, that is based on the delivery date. Having two relationships makes it easy to compute both the order received and the order delivered. I have already the order received measure in my model, and order received is actually a bit larger. Okay, order received is just a distinct count of the order number. Why is that a distinct count? Well, because if we take a look at sales, where is sales? You see that order number has a lot of duplicates. The first value, 10,000, is already a duplicate, but the same happens for other values. Here we have 4 duplicates. That is normal. A given order has multiple lines, so the order number by itself contains duplicates. So if I want to know how many orders I received, I need to do a distinct count of the order number. Now, distinct count has some issues. Distinct count might be slow on high cardinality columns, and distinct count is non-aggregatable. You cannot sum distinct counts and compute a good value. So distinct count requires computing and recomputing the same value multiple times. However, I can write order received in a very simple way by just using a distinct count. What about order delivered? Well, in order to compute the order delivered, I can just write a new measure, and that measure will call order received, so it's orders delivered. I need to use calculate because I want to change the active relationship. So I use the measure order received, but then I activate the other relationship, the one between sales delivery date and date. Order delivered, we just need to format it with commas, we place it in the matrix, and that very quickly computes the number of orders delivered. So you see, I received 2.4 thousand orders and I delivered only 2.3 thousand, meaning that I have around 100 orders which are still to be delivered. And I want to compute that number, how many orders I still have left to deliver. The problem of computing this value is that it is not enough to subtract one from the other. If I subtract from the orders received the orders delivered, I have the delta of the current month. But in order to compute the number of orders which are still open, I basically need to take the previous value, so the previous amount of orders that I still had to deliver, and then add to it the difference in this month. So it's an incremental calculation that starts from the beginning of time and accumulates orders, adding the delta of each individual month. The thing is, computing these calculations in DAX proves to be extremely hard. If you were to do that in Excel, that would be super simple. The previous row plus the difference between two columns and problem solved. But the value of a column in the previous row, that is not something that is easy to compute just by using DAX. However, with DAX, we can use a different approach. We can compute the running total of the orders received and delivered. So I start summing values from the beginning of time, then I grow, and on each individual cell, I compute the sum of all the previous values. If I compute the running total of the orders received and the running total of the orders delivered, then subtracting one from the other produces the number of open orders. And we can easily do this calculation. However, it's going to be a heavy calculation. So let's start by computing the orders received. Let's call it received running total. We can use calculate. We compute the orders received, but then we need to place a filter over the date to make it a running total. So the date needs to be before the last visible date. So just write date less or equal than the max of date. Again, that's a simple calculation because it calls order received for all the dates that happen to be before the last date. We drop it in the matrix and we format it in a nice way. And you see that it computes a good value. 2.4, 2.3 starts with 2.4 and then accumulates values. Let's make it bigger. It starts with 2.4 and then it accumulates values, always growing. So the value shown here, 19751, is the sum of all these values together. That is for the received running total. We need to do the same for the delivered running total. So I just copied the measure, so we have to write less code, and we compute delivered running total by calling orders delivered with date less than the max date. This time we format it immediately, then we place it in the matrix, and we have our second number. Reach this point, it is now enough to subtract one value from the other in order to compute the number of open orders. And that's easy. We just go here, write a new measure that we call open orders, which is just the running total of the received minus the running total of the delivered. Again, we format the value, we place it in the matrix, and we have our value. So this tells me that at the end of January, I had 102 orders, then 178, 43, 103, and this is just the number of open orders. Now, it looks like it's very fast and very easy to write. Unfortunately, the problem is, by writing the code this way, I'm using the cache because I have already written and opened this file once. If I want to evaluate performance of this query, bad surprises are waiting for us. And the big problem here is that, let's look at running total. The running total needs to compute the value for all the dates that happen to be before a given date. So think about that. when you are in February, you need to accumulate values for January and February. When you are in March, you need to perform a scan of the fact table computing January, February, and March. If the measure were additive, the engine could compute individual values and then sum them together. But here we have a problem. Orders delivered as well as order received is a distinct count, and distinct count is non-additive. Therefore, the engine needs to perform a scan of the entire table every time it needs to compute the value for one given month. Therefore, performance is not going to be very good. But we want to measure that, so we just launch the performance analyzer, start recording, refresh the visual, look at the matrix, we copy the query, place it here, and we enable server timings, and then we run the query. Let's look at server timings. You see, it's slower because now the engine cleared the cache and it is actually executing the code. If I don't remember bad, it's taking around 10-15 seconds to run the entire query. Oh, by the way, right now it's probably taking longer because I'm computing multiple values, but still, what I wanted to see is exactly this value. It's taking 14 seconds. If I run it now, again, it's going to be a tiny bit faster, but still 14 seconds is a huge amount of time. 11 seconds, 12 seconds actually are spent on the storage engine CPU, and the Formula engine is not doing a lot. If you look at the number of queries, we have something like 271 queries. Why do we have so many queries? Because there are around 10 years of data in my model, and for 10 years that means 120 months, a bit less because the last month is incomplete, but let's take 110 months. So the engine needs to execute 110 queries in order to compute the orders delivered. Remember, every cell requires a full scan of the table. And that is for the order delivered. Then we need to also do the same for the order received. So 110 times 2, that's 220, plus subtotals and queries like that, that generates 271 queries, each of which is very fast, each of which is the same pattern. It's always select distinct count of the order number with a join over date with a condition over the date that restricts the dates which are interesting. That is a running total, so every day we need to scan all the previous dates. And this filter is going to change for every query. The thing is, this is a very heavy query, and it depends on the size of your fact table. The larger your fact table, the slower it will be. I think the model I'm using has around 100 million rows. I don't remember exactly, so let me check that. Sales contains, no, actually it only contains, you don't see that, let me zoom in. So you see, sales contains 2 million rows, so it's not really large, and it is still very, very slow. If the model were larger, performance would really, really be bad. So how can we improve this? Well, the idea might be focusing on the values which are being computed, because we know that DAX is going to scan the table multiple times because there is a distinct count, and so the engine takes for granted that the measure is non-additive. But as humans, we know better. We know that actually the distinct count needs to be computed for order received and order delivered. But for the running total, we no longer need to compute a distinct count. We can just sum the previous values. So the running total is actually additive if only we were able to base it on the order received and order delivered calculation, which are fast because they are not performing multiple scan of the fact table. What if we accumulate received and delivered as 2 columns, and then we rely on visual calculation? Visual calculation do not compute on top of the model. They compute on top of the virtual table that is created by the first query. So we do the running sum in a visual calculation rather than in DAX. Let's save by the way, the server timings right now. Okay, so we have the numbers at the beginning. That's 14 seconds, the execution time. So let's get rid of everything from here, and then we move to a visual calculation. We need to get rid of received, and open orders. So we only have order received and order delivered. And then we compute the two running totals with a visual calculation. So we start with a new visual calculation, and we call it received running total. We just use running sum of received on the rows. And we have the value, 248, 5711, so the numbers are fine. We can do the same for the delivered. Now from here, new visual calculation, delivered running total, and that's a running sum of the orders delivered over the rows. And again, I have my value. You see, this value is the same as this, and this value is the same as this, apart from formatting, but we're not interested in formatting right now. And the open orders, that's just simple. Open orders is just the received running totals minus the delivered running total. So we have 102, 178, 43, the same numbers we had before. But this is going to be much faster, or at least that's exactly what we hope. So let's go back to the report and let's measure that. We still have performance analyzer. Let's clear everything, refresh the visual so we get the matrix. We copy the query, and then we paste it here. Server timings is still enabled. I have the previous timings. Let's run this. I would expect this to be much faster. And indeed, it runs now in less than half a second, so it's much better than before. And if we take a look at the queries, we have one storage engine query that that computes the distinct count at the month number level, so by year and month. Another one that computes again the distinct count with the different granularity, and then by year the distinct count. And again, by year, a distinct count. So we basically have strongly reduced why are two? Oh, because that is on delivery date. So let's start from the beginning. We have one query using order data and another query using delivery data. So we actually need two kind of queries, the individual months plus the totals times 2, because we have two different relationships. But we went from 270 queries to 4 queries. That is much faster. That also reflects in the time required to compute the value. So it looks like visual calculations are actually a very good solution. And indeed they are, because it's just a matter of two running sum and a subtraction, and the problem is solved. However, we do have a small issue. Visual calculation, they work on the virtual table that is created as part of the first query. And that virtual table only contains the year, the order received, and the order delivered. The next column, receive running total, deliver running total, and open orders, these columns are added as visual calculations. So these are the numbers that the engine can use to perform the calculation. What happens if through a slicer I reduce the number of years? For example, I can get rid of 2015 and 2016 or 2017. I remove a few years. What happens is that the virtual table will not contain the number of orders received and delivered before the beginning of the selection. And as such, it is not able to use that information in order to compute the correct number of open orders. Basically, a visual calculation behaves as if the selection made by Slicer restricts the model, and there are no ways you can go outside of that, because visual calculation cannot access the model. They can only access the virtual table. So if let's say that we start with 2018, you see that starting from 2018, it starts with minus 23, which doesn't make any sense, because it is true that the number of, let's do that this way, The number of orders received is less than the numbers of orders delivered, but that doesn't mean that we have a negative number of open orders. The problem is that we still had a queue, a set of orders before January 2018 that should be added to this number, minus 23, and a visual calculation cannot access that value. How can we solve that? Well, we need to ask help for DAX, because while it is true that a visual calculation cannot access data that happen to be before the currently selected period, well, actually DAX can do that. DAX can go back to the beginning of time because I can write a DAX measure that tells me what is the balance, the number of open orders at the end of the period before the first visible date. So I can create a measure that computes this value, and once I have the measure, I will be able to use it in my visual calculation as an additional column. So the two tools, DAX on the model and visual calculation, can work together in order to solve the scenario. Let's do that together. We need a measure. Let's call it initial balance. Let me see how I name that in the model. So I use the same name, starting value for open orders. Okay. Starting value for open orders. And I need to compute the value of the running total of orders before the beginning of time. So I use calculate. I compute the first date in the visual, and that is the minimum of date data. Actually, I need to compute the minimum in a variable. The first date in the minimum date data, and then I return calculate the received running total minus the delivered running total. That is the opening balance. Remember that the measure is called the starting value for open order, so I can just compute the subtraction between the two. Where the date is less, it's strictly less than the first date in the visual. Actually, this mean date is not computing the first date in the visual. Right now it's computing the first date in the current cell. We want the first date in the entire visual. That's why I use this calculate at the beginning, because we're going to use all selected over date. So this code is not trivial, and it's worth spending a few seconds describing it. First, we use all selected to get rid of any filter from the current cell and go on the visual level, so on the filter context that is active for the entire visual. In this filter context, we compute the minimum date, the first visible date, the 1st of January 2018 in the example we were looking at before. And then we compute the difference between delivered and received and delivered for any date that happens to be before the current visual. As a measure, this is able to compute values which are outside of the current filter context. We can add this to our visual, and the number that I would expect is the same everywhere. At the beginning of January 2018 or at the end of December 2017, we still had 171 orders that were open. So it's enough to compute the sum of this value plus minus 23. And that can be done by changing, or we can do that from here, by editing the calculation for open orders and say that's the received running total minus the delivered running total plus the starting value for open orders. That is the same value everywhere. And this leads to 148, which is the correct value. Then, of course, we hide the columns that we are not interested in, and we obtain order received, order delivered, and open orders. That is a correct value. There's a price to pay, of course, because we have an additional measure to compute. But as usual, we can measure that. So let's clear everything, refresh the visual. look at the time needed to compute the matrix. I forgot to save the timing for the second version. Let's do that again. Refresh the visual. Again, copy, refresh. I lost the code of the query. We have it. Let's run it. It's going to be a bit slower than 455, and indeed it's around a second. Let's add some comment. This is just DAX. This is Visual Calc. And this is Visual Calc with initial balance. However, despite taking around 1 second to run, it is way better than 14 seconds, that is the code of the initial measure. So the first conclusion is that visual calculation alone cannot solve the problem. However, visual calculation plus some help from DAX, they provide a good solution to the problem, increasing the speed by a lot, because you move from 14 seconds to less than 1 second, with code that is rather simple to author. However, as we are DAX experts and we love DAX, now that we have a better picture of how to improve performance, that is, first compute orders delivered and orders received in the virtual table and then compute the running totals later, we can use the very same pattern in a DAX measure. Maybe we get better performance, maybe we get worse performance that we don't actually know. Actually, I do, because I did it already, and performance will be better. But we will have a model measure that is easier to reuse in different visuals. So let's start writing together the code just using DAX. The name that I used was Open Orders DAX Optimized. So let's go here and let's get rid of everything because we used everything from here. So I need to go to the visual calculation editor and then we kill all the calculation. We only have open order received and order delivered as we had before, and we solve everything with a new measure. So let's go there, new measure. I said open orders DAX opt, open orders DAX optimized. So we first accumulate in a variable the monthly values for the delta. Because this is a model measure, we could do that at the month level. And actually, in the demo files that you can download with the article, you will find also a super optimized version that computes values at the month level. But because we are building a generic measure, we can do that at the day level. So we go at the bottom granularity and we build a measure that works in any scenario, with the months as we are doing here, but also at the date level or at the quarter level or any other level in case the measure is used in a different visual. So we use a variable and we don't store the received and delivered because we are actually interested only in the difference between the two. So we create a variable deltas and we use add columns. All day date for every date, no matter what selection is being made in the visual. So for every date, we compute the value of the delta. That is the orders received minus the orders delivered. I can just use the two measures because one is a distinct count, the other one is a distinct count with a different relationship. And then we can compute the result, but in order to compute the result, first we need the last date in the visible filter context. So we store in the variable max date, that is the maximum of date. And then we compute the running total on top of the deltas variable. So we compute straight the result by using sum x over delta, so we do not need to go again to the fact table, where date, so the date in the deltas table, sum x actually SumX, not delta, SumX filter deltas where date is less or equal the max date. So this filter is computing the running total, and it's doing that on top of the deltas variable, so it's not requiring further scans. This reduces the number of rows that I'm interested in looking at, and then the column that I want to use is delta. Return result. Now this is just code. This is no longer trivial DAX code. This is DAX code that you need to have some knowledge in order to write. But the good advantage is that it's a model measure, so it can be used in any visual with no issues. It's already formatted, we need to add commas, and that's it. We can take the measure, drop it here, and it computes a value, 148. If you remember, that's the same value we had before. It's a correct number. The thing we need to worry about is performance. Before performance, note that I have a filter 28 to 2014. We can actually get rid of the filter entirely. So we compare the same amount of data. So we start with 102, 178, 43, same numbers. And then we need to check performance. So again, performance analyzer, clear everything, refresh the visual, open the matrix, copy the query. We go here and we run the query. The last time we executed the query was running in 890 milliseconds. Now it's running in 900 milliseconds. So it's around the same time, which is kind of surprising from my point of view, because that was faster when I started the first time, but it is at least as fast as the previous one. Probably during recording the video, the computer is doing other calculations. However, it is as fast as a visual calculation, and it is doing the calculation at the day granularity. If we move the calculation at the month granularity, that is going to be even faster. The good thing is that it is a model measure, so it is more flexible and can be used in any visual with no problems. So, what is the lesson to learn? There are different tools. And having different tools, you have the option of choosing the one that you prefer. Using just DAX with a naive version of the code isn't going to produce good performance. By the way, I forgot to mention that in the article you will also find a version that uses window functions. Despite looking easier to read, it is still slow. So window functions in this specific case are not helpful because of the distance count. So just solving with DAX, with regular DAX, is not going to produce a very good solution. However, using visual calculation is a very good option. Visual calculations are good, they are simple, the code to author is just a couple of lines of DAX code that anybody can author. The problem is with visual calculation that visual calculations are tied to the virtual table created by the first matrix. So if data there is not enough, you need to add additional measures to provide the numbers that are needed in order to compute the correct number. So visual calculations are a good solution, but sometimes you still need the help from measures. And once you have understood that visual calculations are a good solution because they reduce the granularity of the calculation, then implementing the same technique with a DAX measure is actually your best option. Because in that case, you build a DAX measure that is at least as fast as a visual calculation, with the great advantage that it works in any scenario, in any model, in any matrix. You can just add the measure and it works. Besides, the version we created was working at the day granularity, whereas the virtual calculation provided that timing at the month granularity. If you increase the granularity at the day level, visual calculation will be slower because the number of rows in the virtual table, of course, they will be larger. However, from the DAX standpoint, the more you know, the better your DAX code will be. Visual calculations are not an alternative to regular DAX measures. Both techniques can be used in order to solve the scenario of your specific data model in the best way. Enjoy DAX!